So if we talk about electrical power, we're going to first want to talk about just power in general. We know power is how much work we do in a period of time or how much energy in a period of time, and we get our power in watts, joules per second. All right, so we've already derived the power equation, current times voltage, to get power. And if we use Ohm's law, we can, rearrange this to get what we need. So V equals IR, right? So if we want to, instead of using voltage, we could place this in for voltage, and then we would have I times IR, right? Which would be I squared R, is equal to the power. So if you just have resistance and current, you can figure out the power. Or if you rearrange the equation, V equals IR, and we can replace this in for current, V over R. We place this in for current. We would have V over R times V. So we'd have voltage squared over resistance will give us the amount of power. So how much current flows through a 100-watt light bulb connected to a 120-volt DC power supply? So if you want to pause the clip and give this a try, you can do that, and then when you're ready to check, you can hit play to continue. Okay, so our current is 0.833 amps, and we can find the resistance here. We know the current, and we know the voltage. So we can find the resistance of this bulb at that particular voltage, and we get 144 ohms. Okay, so how many kilowatts of power does a computer use if it's connected to a 120-volt source and has a total resistance of 175 kilo ohms? So I'll let you go ahead and try this one. You can pause the clip and give this a try, and when you're ready to check, you can hit play to continue. Okay, so 120 volts, we've got a resistance, and we can find our power this way. So 0.08229 watts, and we convert to kilowatts, and that's how many kilowatts we have. And then after an hour, how much do we use? So you can try that as well. So go ahead and pause the clip again and give that a try, and when you're ready to check, you can hit play to continue. Okay, so 3,600 seconds, and we have our power, and which we would need to use the original wattage, and it would be using 296.23 joules in an hour.